Please subscribe to our channel, like this video, and press the notification button to know our upcoming videos.
You see it every single day, but have you ever really stopped to think about what's going on with your reflection? It's probably one of the most common things we experience, but it's also one of the most fascinating. I mean, really think about that for a second. It's not a screen, there's no projector, it's just a flat, shiny surface, and yet somehow a perfect copy of you is staring right back. So how does it do that?
Well, the answer isn't magic, even though it kind of feels like it. It's pure physics, and it's surprisingly simple. To finally solve the mystery of the mirror, we just need to learn how to speak the language of light.
Okay, so to crack this thing open, we have to start with the absolute basics. We're going to build this whole idea from the ground up, starting with how scientists even begin to visualize and measure something as wild as light. So, first things first, I want you to forget about light as this big, fuzzy glow. Instead, just picture one tiny single ray of light shooting out from a source in a perfectly straight line. We call this the incident ray. Think of it as the incoming ray, heading towards whatever it's about to hit. All right, next we need a reference point. And honestly, this is the most important tool in our entire toolkit. It's called the normal line. Now, you can't see this line, it's totally imaginary. It's just a guide that we draw at a perfect 90-degree angle to the surface of the mirror, right at the exact spot where our light ray hits. Everything we measure is based on this line.
So now that we have our normal line, we can finally take a measurement. The angle of incidence, we just call it I for short, is the angle between that incoming light ray and our imaginary normal line. That's it. It's basically the angle of approach.
And of course, what happens when light hits a mirror? It bounces off. We call this departing beam the reflected ray. And the angle that this bouncing ray makes with that same normal line? Well, you guessed it. That's the angle of reflection, or R. It's our angle of departure.
All right, let's recap. We've got our incoming ray, our outgoing ray, and the angles they both make with our normal line. We have all the pieces. Now we can finally reveal the one incredibly simple rule that governs literally every reflection you have ever seen in your life.
And this isn't just, a suggestion for how light should behave. It's a fundamental law of our universe. Whether it's your bathroom mirror or the surface of a still lake, this rule is always being followed. It cannot be broken.
And here it is, so simple. The angle of incidence is always equal to the angle of reflection. Angle I equals angle R. That means if a light ray comes in and hits the mirror at a 40-degree angle to the normal, it is going to bounce off at a perfect 40-degree angle every single time. That's the golden rule.
Okay, so angle in equals angle out. Simple enough, right? But how does that simple little equation create a perfect, detailed, three-dimensional U that seems to be living behind the glass? Well, this is the really cool part. This is where our own brains get involved and, frankly, get tricked.
You see, your brain has learned a very important shortcut over millions of years. Light travels in straight lines. It sees a ray of light coming into your eye, and it just assumes that ray has been traveling in a straight line forever. Your brain doesn't know about the law of reflection. It has no idea the light just did a bounce, and that's where the illusion starts.
So let's trace the path. Light from, say, your nose travels to the mirror. Step 2, it reflects off perfectly, obeying our golden rule, I equals R, and heads straight into your eye. But here's the trick. Your brain sees that ray coming in and just traces it backwards in a straight line, as if it came from behind the mirror. And when your brain does this for the millions of rays bouncing off your face, they all meet up at a point behind the mirror, and boom, that's where it constructs the image of your face.
Physicists have a name for this illusion. They call it a virtual image. It's virtual because the light rays aren't actually there. They just appear to be coming from that spot behind the mirror. That's why if you put a piece of paper behind a mirror, nothing shows up. The image doesn't really exist in that space. It's just a beautiful optical illusion created by physics and your own brain.
So, to sum it all up, this physics guarantees three things whenever you look into a simple, flat mirror. 1. The image you see is the exact same size as you. 2. It appears to be the exact same distance behind the mirror as you are in front of it. And 3, as we now know, it's always a virtual image.
Now, this whole I equals R thing, it is so much more than just a neat trick for bathroom mirrors. This one simple principle is a cornerstone of modern technology. We use it absolutely everywhere.
I mean, just think about it. The mirrors inside a high-end camera that bounce light perfectly onto the sensor, that's our rule. A periscope on a submarine that lets you see above the water, that's just a couple of mirrors using the rule. Even the mind-blowing technology of fiber optics, bouncing light signals down a tiny glass thread to bring you the internet, it's all powered by that one simple idea. The angle in equals the angle out.
So the next time you catch your reflection in a shop window or see the sun glinting off the surface of a lake, you'll know exactly what's going on. You'll see that elegant, unbreakable law of physics playing out right in front of you. Kind of makes you wonder, right? What other bits of everyday magic are just waiting for us to find the simple rule that explains it all? Pretty amazing stuff. Thanks for diving into this with me.